All right, number 3. So factor the following quadratic, and then we're going to expand the answer that we get from factoring to see if what we got from factoring matches. So expanding is kind of our way of checking if we're right or wrong, right? So that's what's over here with the table method, right? So I've been saying for the last little bit here, we're going to look at, if we look at the word man itself, and this has kind of worked for a few students, is the word man itself, the A is in the middle of the word. So I know the A is going to go on the middle term in the middle, right? So I know that to factor this, the two numbers that I'm going to ultimately solve for or find have to add to -6. So that leaves, there's no number here, so that's not really interesting. So the M must go over here on the 8. So I'm going to need to find two numbers that multiply to 8 and add to -6. And so I normally just start at, I always know that I can always multiply the number times 1. So I'm always checking to see if I can multiply first, and then I can manipulate the numbers with negatives to see if they add. So I'm going to go 1 times 8. Now there's no combination of 1 and 8 that's ever going to add to -6. So it doesn't matter if I make both these negative, -1 plus -8 is never going to add to -6. So we get to kind of ignore those, right? So then we go to the next number. So I started with 1, and then I'm going to go to 2. So 2 times what equals 8? Well, it's 4. But if I were to add those two together, it's not going to be -6. It's going to be +6. So that's not really useful. But I can make both of these negative, in which case when I add them together, I get -6. But they just so happen to multiply to 8. So that satisfies both the conditions. And what's nice about this is once I get these two numbers that are right here, the two numbers, so -2 and -4, I simply just get to write the variable from the question. In this case, it's x. I get to write it in front of these two numbers. So x minus 2, x minus 4. That's it, factored in factored form. Now I'm going to do something else here. So that's the answer for the first box. That's the answer. That's it, factored in factored form. This one moves over. Now, the other side of things is, if we were to provide you with this initially and ask you to expand it to produce this, we could ask you that. This question, I've asked you to expand what you get as an answer from factoring to see if you get the same trinomial, right? That's a big word. The same parabola as what we started with there. So most of you are okay with this. This is the easier of the two. So I'm going to take each piece and I'm going to write it one horizontally and one vertically. So one, I'm going to write the x and the -2, and then I'm going to write x and -4. And my job is to fill in the middle section of this table to produce the trinomial pieces. You remember these when we were working with algebra tiles. This was the length, or this could have been the width or the length, and the length would have been here. When you multiply, it doesn't really matter what order things go in, so it could have been either or. But now I'm just going to simply produce the area, and I know the area of a rectangle is length times width. So I'm just going to multiply the length by the width. So x times x is x squared. X times negative 2x is negative 2x. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. And then I get to take the area, in this case everything on the inside, and write it in one line. So I'm going to write x squared minus 2x minus 4x plus 8. Right, that's y equals. And then I see that I have some like terms floating about in the middle. I see the x and the x, and I see that there is negative 2 of them here and negative 4 of them there. So I get to condense this down, and I get to rewrite this as y equals x squared negative 2 minus 4. So I'm sitting at negative 2, and I'm going to go negative or 4 more to the left. That's going to result in negative 6x plus 8. And you will see that this confirms, because this matches the original, I must have done my factoring correct in order to produce something that I can expand and get the original back. So then I know I'm okay and I'm good.